Hello dear students, Assalamu alaikum. This is Darshan, lecturer mathematics at Govt Islamia Arts and Commerce College, Sukkur. This is my third lecture for first year class mathematics, and in this lecture we will discuss exercise 7.1 and question number 2 and 4 of our exercise 7.1 of our textbook. Question number 2 is that there are 53 students taking mathematics, physics, or both, and 38 students are just taking mathematics, and 40 students are just taking physics. Now question is that how many students are there taking both maths and physics? So we have to find number of the students who are taking both maths and physics. Secondly, we are said that how many students are taking maths but not physics. And in third part, we are said that how many students are just taking physics but not mathematics. So, firstly, we will discuss number one, part one of this question, that how many students are taking both maths and physics. Both maths and physics, that we know that there are just 38 students are there in maths, taking maths, and 40 students are taking physics. So we want to find number of students who are taking both maths and physics. Means we want to find intersection of M and P, where set M denotes the number of students taking maths and P denotes number of students, set of the students taking physics. This is for physics. Okay, so we have some principle for accounting, that number of elements in the union of M and P is equal to the number of elements in M plus number of elements in the uh, P and number of elements in the intersection of M and P. So we are said that there are 53 students taking maths, physics, or both. So number of elements in the union of M and B is 53, and just we are said that 40 students are taking maths, 38 students are taking maths, and 40 students are taking physics. So we have to find that how many students are taking both maths and physics. So according to this calculation, we got that there are 25 students who are taking both maths and physics. And second part of this question, we are said that how many students are taking mathematics but not physics. So mathematics but not physics means we want to find that how many elements are there which are taking mathematics but not physics. Not physics means we have to find complement of P and we have to find the intersection of M and complement of P. So according to again some principle, we have number of elements in the M intersection P complement is equal to number of elements in M minus number of elements in the intersection of M and P. So there are 38 students who are taking mathematics, and in part 1 we found that there are 25 students who are taking which are taking both mathematics and physics, who are taking both mathematics and physics. So difference of 38 and 25 is 13. So there are just 13 students who are taking maths. And in next part, we are said that how many students are taking physics but not mathematics. So simply we want to find that how many elements are there in the intersection of M complement and P. So again, some principle will be here, will be used here. So it will be number of elements in the complement of intersection of complement of M and P is equal to number of elements in P minus number of elements in the intersection of M and P. So there are 40 students who are taking physics, and in part 1 we got that there are 25 students who are taking both maths and physics, and after all we found that there are 15 students who are taking just physics but not mathematics. It was all about question number two. Now come to question number 4. In question number 4, we are said that there are 4 persons enter in a first class railway compartment in which there are 6 seats, 4 persons and 6 seats. In how many ways they can take their seats? Okay, so we have 4 persons and 6 seats. In how many ways we can uh, they can take their seats? So first person have 6 choices to take a seat. Second person has 5 choices. Third person has 4 choices, and fourth person has 3 choices. So according to the fundamental counting principle, we have to multiply all these things. So the product of 4, 5, 4 and 3 is 360. So we have 360 ways in which these 4 persons can take their seats out of 6 seats. Thank you very much.